All right, so went ahead and started this new one. Question 13 definitely got to my head a little bit. I was kind of confused by that. But then what I did, and Mr. Fossum did as well, we made a table of values and just analyzed what the change would be. So I'm going to say, I'm going to analyze what happens to my y as I increase my x by 1. So it says, suppose the value of x changes by 1, how much does the value of y change? So if my x is 1, then y is 9 times 1 is 9, take away 2 is 7. Okay? If my x is 2, because I have to increase by 1, y would be 9 times 2, 18, minus 2 is 16. If my x is 3, what happens to my y? And so I would go 9 times 3 is what? 27 minus 2 would be 25. And I'm just going to analyze what is my change here. Maybe I'll do one more just to get enough values here. 9 times 4 is 36, minus 2 would be 30. That's a 3, 34. So now what I'm going to do is just check to see how did my y change. So from 7 to 16, I do big number minus small number. That looked like it changed by 9, so I added 9 to it. And then 25, from 16 to 25, I'm going to go 25 minus 16 is 9. And then I'm going to go from 25 to 34. So 34 take away 25 is also 9. So it looks to me as my x increases by 1, my y increased by 9. So I would type in 9 there. The next one was a little more confusing. Part B says that suppose the value of y changes by 27. How much does the value of x change? So that means now I'm making a table of values, but I'm going to have to use algebra. So I have to keep in mind this is my equation. 9x minus 2 is what always has to happen to the x, and y is going to change by 27. So what I did is I thought, oh my goodness, I have no idea. So I went ahead and made a table of values again, x and y. So let's say that y is 0. Okay, so if y is 0, I got to figure out what x would be. So 0 equals 9x minus 2. And this is not going to be pretty because it's going to definitely be a fraction. So I'm going to add 2 to both sides, and I would get 2 equals 9x. So 9x, and then you'd have to divide by 9. And now it's not 9 divided by 2, it would be 2 divided by 9. So divide that by 2, and that is 2/9. So my x is 2/9. 2/9. Okay, so my next one, my y has to increase by 27. So now I'm going to put a 27 in. 27 has to be my y. Let's see if I can erase some of this. So now I have to figure out, yeah, that is an eraser. It's just very slow. I have to figure out what my x would be. So I'm going to do the same thing I did with my 0. I'm going to say 27 is equal to 9x minus 2. So here I go. 2, 7, oh, waiting. Oh, it's in the eraser. So 27 is equal to 9x minus 2. So I'm going to add 2 to both sides. And when I add 2 to both sides, it's going to be 29 equals 9x. So I'm going to have to isolate my x. So I'll have to divide through by 9 because that's what's sticking to it. And it's not going to be pretty again. It's going to be some random, it's going to be 29/9. So now I have, the next one is 29/9. 29/9. So if you recall what we did with our x's, we just the y's on the last one, we just found how they changed, and how they changed was the difference. So what I'm going to do here is, I already know that my y changed by 27. Now I'm going to see how my x changed if I went from 29 ninths, from 2 ninths to 29 ninths. You go big minus small. So you can do that in your calculator by doing parentheses with yours. So you could go 29/9 parenthesis, take away the 2 ninths, take away parenthesis 2/9. And that will give you, ooh, a perfect number. So it looks like your x value changed by 3. So again, that was kind of complicated, but our strategy here was to create a table of values, and the y, you had to just use a little bit of algebra. Okay, number 14 is a nice little mental break compared to that one. So what is the solution to this equation? That means what is it? So I have x on both sides. I have to get x to one side. So the proper etiquette is to move your smallest one. So I'm going to add 4x. And some of you, if you are one that does the inverse or plus a negative, I'm going to just show you how that would work. So if you turn this into plus a -4, what you're really doing is subtracting a -4 to both sides, a -4x, and that's a plus. So I'm adding 4x to both sides, so plus 4x, and that gets rid of that minus 4x over there. So I have 6x plus 4 more is 10 of them left. So I have 10x minus 25 is equal to 45. Okay, so sorry if you hear my family talking in the background. So now I'm going to add 25 to both sides. You move what's not sticking to it. I can't do that in my head, so good thing you get a calculator with this one. 45 plus 25 is 70. So now after we add 25, and again, if you're a plus a negative kid, that's fine. What you're really doing is minusing -5. That's a plus. So we are plussing 25 to both sides. Plus 25, and that was 70. Good thing I'm taking forever doing this. So 10x equals 70, and then you would divide by 10, so x has to be 70 divided by 10 is 7. So x is 7, and you have plenty of time to check your work, so they should equal each other. So what I did when I created this key is I checked to make sure I found the right x. So I went 6 times 7, take away 25, hit enter, that's 17. And then I plugged my 7 into the second part of the equation. 45 take away 4 times 7, and that is also 17. So you did find the correct solution. All right, number 15 says no calculator. So this would be one you cannot use a calculator for. You have to be able to remember the strategies by yourself. Okay, find the product in both scientific notation and standard form. So scientific notation, if you look here, it's like a number times 10 to some kind of power. And standard form is when you would write it out the long way. It wouldn't be the times 10 to the something. If you recall, what we do is multiply our numbers. So 3.5 times 4. So no calculator. And I don't know how many of you know that by heart, but I know I don't. So I have to do a little bit of tedious math here. 3.5 times 4. And yours will be better. My page marker is lagged because I'm recording. So 4 times 5 is 20. So write the 0, carry the 2. 4 times 3 is 12, plus 2 is 14. And then what do we have? One spot, so it's just 14. So it's 14 is our main number, so it's going to be 14. And then with scientific notation, remember it's the multiplication property of exponents. When you have the same base, you can add the exponents. So I have 6 tenths and -4 tenths. So I can say 14 times 10 to the, and then you add them. So it would be 6 plus -4. Oh, I forgot my negative sign. So -4, which is 14 times 10 squared. which is just 100. But I need that for when I do the scientific notation part. Okay, so standard form is normal number. Like, what is 14 times 10 squared? You can't use a calculator. So that really what that means is move a decimal 2 spots to the right. So if I moved it 2 spots to the right, my decimal is already right here, so I would need 2 placeholder zeros. So it'd be 1400. So that would be 1400. That standard form is 1400. I'm going to have to wait to type that up. Actually, I'm going to not forget what I have. It's 14 times 10 squared. Okay, so 1400. Or you can be super proper and write 1400. And then our scientific notation. So it was 14 times 10 to the squared power, but that's not proper form. It's not proper form because you should have a decimal right between those two numbers. So I need to change this. And if you recall our strategy, I need to make it 1.4. So I'm going to make 14 1.4. I made the number smaller. You have to balance it out. Since I made my number smaller, I have to make my exponent bigger. So that's 1.4 times 10 cubed. No calculator. I will just show you that it's correct, though. If I went 1.4, whoopsie. If I went 1.4 times 10 to the, that's the to the button, to the third, enter, and that's the 1400. But that's going to do you no good because you can't use it. Okay, number 16. Which pair of line below forms a system of equations that has no solution? No solution means that they're parallel, is really what no solution means. It also means that when you solve it algebraically, whether you do linear combination or substitution, when you solve it, you're going to get something like 0. Everything's going to cancel out on the left side, and then it's not going to cancel out on the right side. So it would be like 0 equals 5 or something. So this is a lot. We want to know which pairs, so we got to connect the two, solve each system. So 1 and 2, 1 and 3, 2 and 3. Find out which one creates a no solution. So instead of me doing it all, I felt very overwhelmed by that. I just go to my multiple choice to see what they want me to do. So I'm going to try systems 1 and 2. So here I'm going to write it out. 3x minus y equals 7. I wish I could write this better. Is equation 1. And then it wants me to check equation 2 is 4x minus 2y is equal to 8. So my go-to strategy for systems is elimination or combination, linear combination or elimination, whatever you want to think. So I see the easiest way would be to cancel out my y. So I'm going to times my top equation by a -2 because that would give me a positive 2y since I have a negative y there and my y's can cancel. So -2 times 3 is -6x. And then I'm just going to show you that this is plus a negative. So -2 times -y would be a positive 2y. So plus positive 2y plus 2y. And then don't forget to distribute to the other side of the equal sign too. -2 times 7 is a -14. So I am also going to keep my eye on the prize, knowing that I'm looking for something to cancel out. So if nothing cancels out, I can just be done. I don't have to go through the whole process because I want no solution, which means the left side needs to cancel out and the right side doesn't cancel. So 4x minus 6x is a -2x. So my x didn't cancel out and I wanted it to be. So right away I can tell that it's not this one. Okay, all that work, and now I get to do my next one. So I know it's not this. So now I'm going to compare 1 and 3. So equation 1 is 3x minus y is 7. Minus y is 7. And equation 3 is 6x, right, kind of good, minus 2y y is 9. Okay, so I'm going to go ahead and eliminate. So I could turn my x term into a -6 or my y term to a +2. I'm going to go, I like doing the first term best, so I'm going to times everything by a -2 so I can have a -6x on top. I'm also going to plus a negative here and make my 1 come out. Okay, so -2 times 3 is a -6x. And then my plus sign. And then distribute again. -2 times -1 is a +2y. And then distribute to that 7. -2 times 7 is a -14. And then I'm going to combine. And it looks 6 minus 6 is nothing. -2 minus 2 is nothing. So everything canceled out. That's exactly what I wanted. And 9 minus 14 is like, what, -5 or something like that. So that is not true. That is a no solution. So I know right away it's 1 and 3. If you don't love solving systems, you also could just really get in touch with what no solution means with a system, and that means parallel lines. So you could, with all of these, get y alone and compare the slope. Find the slopes that match. That's another strategy you could use. Okay, the lengths of two shorter sides of a right triangle measure 12 and 15. What is the length of the longest side? So I like to draw a visual. And also, again, if you're confused, I know right away triangle means Pythagorean's theorem. But if you're confused and you're like, how the heck am I supposed to figure this out? You can look at your formula sheet. The best strategy as an 8th grader, you guys get the most formulas, is saying, is there a formula I can use? And since Pythagorean is the only triangle formula, that's the one you can use. So remember the hypotenuse, which is your C, is always the longest measure. So these are the triangles that make, or the dimensions that make up the legs or the right angle. So I'm drawing a visual here. I'm looking for my x, my hypotenuse. So I have 12 and 15. And then what I'm going to do is just kind of pop that into my calculator and figure out, because I know that I would have to, since my right angle is here, I would have to go 12 squared plus 15 squared. That's Pythagorean's. So I'm going to go 12 squared. So 12 squared, let's move this, plus 15 squared, hit enter, that's 369, and then I need to take the square root of 369, because that would be x squared, so you have to square root it, and that's blah, 19.20 something, okay? And I'm going to see if I can find that match. They're all in the radical form, which means square root form. So now what you could do is I see that here's my square root of 369 and here's the square root of 369. They just didn't hit the enter button. So you could do that. Let me close this. Or what you could do is also find the match. Since they still have them in their radical form, you could do the square root of 7 and try to find the one that matches. That's 2.6. It doesn't match your 19.2. You could do the square root of 27, and that is 5.2, doesn't match your 19. The square root of 81, that's a perfect square, so that's 9, doesn't match your 19. So that's the other strategy that you could use. Okay, question number 18. Which line is perpendicular to 3y minus 2x plus 5 is 0? And I gave you a nice little hint here. Get them all into slope-intercept form, which means y alone, and then you compare the slopes. If you can remember, way back in Unit 5 this was, perpendicular lines are the opposite sign, and you flip. So like let's say I had 3 is my normal slope. Oh goodness, that does not look like a 3. A 3 is my normal slope. I make my 1 come out. My perpendicular slope would be make it negative and flip it, -1/3. Okay, and I'm just going to do one more with this one. Oh, gosh. Let's say that I had a slope of a positive 1/4. If I had a slope of a positive 1/4, then my perpendicular slope would be flip it and make it the opposite sign. So right now it's positive, even though you can't tell that's a 4. It's a positive 1/4, so it will be a negative, flip, 4/1, and then the 1 on the bottom always hides. So it would just be a negative 4 would be your perpendicular. So then what we need to do is to isolate y in all of these. So I'm going to go ahead and do that. Okay, so I need to subtract 5 to both sides first. So I'm going to have 3y. I'm going to just let you know that's a 3. 3y minus 2x is negative 5. When I subtract, 2x is negative 5. When I subtract that 5 from both sides. Oh, I better have the negative sign. Okay, and now you move the x term. So I'm going to go ahead and add 2x to both sides. And remember, in slope-intercept, it just kind of smushes in front of that negative 5 because we want the x term first. So it will be 3y, 3 3y equals, and smush that in front, 2x minus 5. Or plus a negative 5, whatever you want. And then go ahead and divide everything by what's sticking to the y. And so I'm going to divide everything by 3. It's going to be like a 5/3, but again, you don't need to care about that because all you care about is the slope. So all I care about is, oh gosh, that's a 3, and so is that. All I care about is the slope because I need perpendicular. So I'm going to slope this, and I'm going to identify what I have here. So we had the slope of 2/3. So our slope, and I'm going to try to write nice, a nice S. Our slope was 2/3. So then my perpendicular slope, I would have to flip it and make it the opposite sign. So my perpendicular slope needs to be a negative 3/2. And again, I'm going really slow and explaining a lot here. This won't take you as long as it's taking me because I'm just going through explaining everything very detailedly. Now, this one's kind of annoying here. What I need to do is isolate y in all of these. I know it's annoying, but you got plenty of time. You are just going to get y alone. I'm going to subtract 7. You don't even need to care about that because all you're doing is analyzing slope. And then I have y minus 3/2 is negative 7. And then I'm going to add 3/2 x to both sides and smush it in front of the negative 7, if I can actually write this. And then when you add 3/2 x, it will be y equals 3/2 x minus 7. So y equals 3/2. And it's not a match because I need it to be negative 3/2. But when we moved it over, it was a positive. So I'm just going to show that the 3/2 x and show that I'm just comparing that. And that's not a match. So that's not perpendicular. Okay, next one. I'm going to minus 4 to both sides. I'm just going to multitask here. I'm going to minus 2x to both sides, and I'm going to minus 4 to both sides. So, minus 2x and minus 4, and I get 3y equals negative 2x minus 4. So, and then what I'm going to do is divide by 3 once I can get this writing down. And I'm going to divide everything by 3, but I can go ahead and stop because as I was writing this, as it took forever, I was keeping in mind that I needed a 3 on top. And this has the 2 on top, so I know that that's not going to be it. Okay, next one. I'm going to minus 3x, and I'm going to plus 2. 3x and plus 2. Oofta. I'm going to do that to both sides. So then I would have 2y equals, and then what did I do? I subtracted 3x. Hey, that looks good because I want a negative 3. Subtract 3x, and then I added 2. Even though, again, you don't care about the second term, also known as the y-intercept. You do not care about that. You're comparing slopes. Divide everything by 2, and you'd get your 2 on the bottom. So divide 2, divide 2, divide 2. And then I do have my negative 3 over 2, so it would be C. Another strategy, if you don't like this, actually, there's no easy way around this one, because you could get y alone on all of these like you have to do anyways. If you didn't remember that perpendicular is flip and make the opposite sign, you could graph them. And when you graph them, you would see that they meet at a 90-degree angle. I erased all that work, but I'll just show you an example. Like, let's say I had 1/2 x minus 3, and I wanted to see if a line met at a 90-degree angle. So I know then that my perpendicular slope would be -2/1. So I'm just going to write -2/1x, and it doesn't matter what this term is. And if I graph it, you'll see that there is that 90-degree angle that they meet at right there. So they are perpendicular. So you can always check to make sure that if you're unsure what the rule was for that. Remember, if it's parallel, you could get y alone and graph them the same way. Parallel means same slope. So you could go, like, let's say I had 2x, I always forget that, 2x plus 1, and then I had 2x minus 6, and I graph them, and I see they're parallel. So you can always get y alone and check there. Okay, number 19. A segment has endpoints 3, 6, and -6, 6. What is the length of the segment? All right, so this one, it wants to know what's the length. If you are unsure of that, I know length means distance. Again, your strategy would be, is there a formula you can use? So Pythagorean, no, you don't have a triangle. Distance, that means how far is it? Length is how far it is. So this is the distance formula. You will have graph papers. So if I just Google graph paper, go to images, you could plot these on the graph paper that you're going to get. And then you could see that you would be able to use Pythagorean's theorem for it. I don't know why this is doing this. But you could plot those 2 points. What is it? It's 3, 6 and -6, 6. So 3, 6 would be 1, 2, 3, 1, 2, 3, 4, 5, 6 right there. And then -6, 6 would be -6 over here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And you could count how far apart they are there too. I'm going to use my distance formula though, just to show you how to type that in. So according to the distance formula, the distance between any 2 points is equal to the square root of the 2 x's, x of 2, second x, take away the first x, square it, plus the second y, take away the first y, square it. So I'm just going to write these 2 points down. I have my x, my y, and then down here I have my x, and I have my y. So now I'm just going to plug into this very lovely formula. So here I go, parenthesis, you have to use a parenthesis, my second x, -6, take away my first x, 3, parenthesis, square it, plus my second y, 6, take away my first y, 6, parenthesis, square it. And I just type all of that into my calculator. And this would definitely be a calculator question. So here's my calc. I'm going to clear it to get out of the graph, and I need this to move from us. So I'm going to go square root. So again, that's above the square sign. So I'll hit the blue square root and then type it exactly how you see it. Parenthesis 6 minus 3 parenthesis squared plus parenthesis 6 minus 6 parenthesis squared. Hit enter and you get 3. They are 3 away from each other. Okay, number 20. The area of a square is 300 square feet. Which of the following is closest to the length of one side? So a square is equal sides. Each of the sides are equal. So you want to know what number times itself is going to be 300, because we have a side length is equal all the way around. So you want an area you multiply. So I want to know what number times itself is equal to 300. So my strategy that I do, I just square root, because I know that I'm saying s squared is 300, so it's the square root. But a lot of kids kind of struggle with that at your age. So you could guess and check. You could say, okay, if it was 13, you could go 13 squared, hit enter, that's 169, definitely not 300. 17 squared, hit enter, 289, kind of close, I don't know. Try 25. 25 squared, hit enter, 625, way too big. Try 30. Okay, so 30 squared is going to be like 900. Yeah, way too big. So 17 is the closest. Again, if you used my strategy, if you said, if I square s, it needs to be 300. Then to get rid of a square, you square a root. And if you take the square root of 300, so square root of 300, and that is equal to 17. Right around 17 when you round it to the nearest whole. So that's that. Okay, 21. What are the first 6 terms of the geometric, and by the way, geometric sequences are like our exponential growth that we just learned about last week, where you have a times b to the x. And the a is the initial amount, and this lovely b here is your growth factor. So just a geometric sequence is an exponential function. So what are the first 6 terms of the geometric sequence generated by this equation? F of x is 32 times a half x for x equals 0, 1, 2, 3, etc. So we need the 6 terms. So I'm going to plug 0 in. Luckily, you're going to have this calc, so it's no big deal. You could type it in exactly how you see it. You can say 32 parenthesis 1 slash 2. You don't get pretty fraction buttons as an 8th grader. To the, right up there, and it looks like I have a 0 power. Hit enter, and that'll be 32. And if you think logically about that too, a half to the 0 means you have none of them, so it cancels out. You'd actually just have that 32. Okay, next one, the first term. So when x is 1, I'm going to plug a 1 in. 32 parenthesis 1 half to the first power. And you don't even need to put it there, but I'll go ahead and do it. And that will be, it's just timesing by a half, so 16. Okay, second one. So now I'm going to put a 2 right where the x is. So I'm going to go 32 times 1 half squared. So 32 parenthesis 1 slash 2 parenthesis squared. Enter, 8. I'm seeing a pattern here, but I'm going to just keep evaluating through. So now it's my 4th term, or x is 4. So, or no, it would be x is cubed. Yeah, because I just did the square one. So it'll be 32 parenthesis 1 slash 2 to the 3rd power. And that'll be an 8th. It should be 4. Yep, 4. And now I'm going to do my 4th one. 32 parenthesis 1 slash 2 to the 4th is 2. Again, you keep, so the next one should be 1. If you look, I'm getting smaller by half. I'm halving everything. And look at this constant, what would this factor, this would be a, not a growth factor, a decay factor, because it's smaller than 1. So it's getting smaller by half each time. Okay, anyways, we're gonna do that 6th term, or 5th term. So 32, parenthesis, 1/2, parenthesis, to the 5th. Enter. And yep, that's 1. Math is all about patterns, 8th graders. So if you identify a pattern when you're solving a problem, you can continue on with your pattern, because most of the time, if a pattern is nice and constant, it's going to stay that way. So you don't have to invest as much time. But I want you to really take your time when you take your test next week. So it's really important to just, you can't do anything else anyway, so why not just plug in and check your answers. Which of the following sums is irrational? Remember, irrational means that your square root is not going to be perfect, or it's pi. Those are the only irrational numbers in the world. So I want to look, when I do this, which one is going to not be a rational number? Which one will not be perfect? Oh, some of you might think this 0.4 repeating or 0.2 repeating is not rational, but it is, because you can turn a repeating decimal to a fraction, if you remember from 7th grade. 7.4 repeating would be 4/9, so 7 4/9. 0.2 repeating would be 2/9, so 5 2/9. So I know right away this is rational because I have repeating decimals. Okay, so now I'm going to do 9 plus the square root of 16. Hit enter. That's 13, so that's rational because it's perfect. Here, maybe I'll write an R if I can. R. Let me extend that. This is rational because it's repeating decimals. Repeating decimals are rational. The square root of 25 plus 64, I can tell you right now it will be rational because this is 5 and that is 8. They're perfect squares. If you don't remember your perfect squares, you can always just use your calc to help you out. So square root of 25 plus, what was the other square root of 64? Oh, too big. I'm going to go square root of 25, and then I got to get out of the square root, plus the square root of 64, and that's a perfect number. Okay, and this would be the square root of 25 plus 64. So square root 25 plus 64, hit enter, and that's not a perfect square root. So that is the irrational number. 23. Points A, B, and C are 3 vertices of a parallelogram. What's the 4th vertex? So I know that A, B, and C are a parallelogram. And parallelograms has to deal with our knowledge of parallel and perpendicular slopes. Parallel means the slopes are the same. Perpendicular means the slopes are opposite. So I need my next vertex to be parallel to this line here. So I'm going to extend. So my strategy here is to figure out what is the slope from A to C. So I know that I'm going down 1, 2, 3, 4, 5, 6, 7. I went down 7. So -7 slash, and then I went over 1, 2, down 7 over 2. So that is the slope of my segment BC or AC. So then I know that B to the D has to be the same. They are parallel. So I'm going to go down 7 over 2. Down 1, 2, 3, 4, 5, 6, 7 over 1, 2, and that's where it would be. So it looks like I'm at 3, -4. So 3, -4. Look at mine, looks like a 7. but that's really a 3. So I'm just going to escape that. Again, my strategy there was to say, okay, I got to have a parallelogram. Parallelograms has that keyword parallel. Parallel means same slope. So I found it by moving the slope from A to C. Remember, slope is rise over run. Okay, 24. Ooh, a nice one that you don't have to do too much. For which scatter plot below would a line of best fit be least predictive, meaning it wouldn't really give you a good estimate? So this, you want to look for one that has no correlation. You could make a really nice line of best fit here. This is a positive correlation. You could make a good one. This is a negative correlation. You could make a good one. And here they're all over the place. So that's the one you can't really make good predictions on. All right, next one. Sally graphed the equation f of x, which is the same as y. F of x is negative 2x plus 5. James then graphed an equation that was a line steeper. A line means 1. Steeper means bigger. So I need to get bigger by 1. Which equation could have been one that James graphed? So I know that Sally's slope is negative 2. Let me make that a little nicer. So Sally's slope is negative 2. If James is steeper by 1, I would go negative 2, add 1 because he's a little steeper. And then what do we have? Negative 2 plus 1 is negative 1. So I want to find out which slope here, which equation has a slope of negative 1. And that would be, this is a slope of positive 1, negative 3, down 1 over 2, and then your 1 is hiding there. So it's D. Again, you can always, you would be able to graph it if you wanted to. If I go to y equals is the same as f of x equals. It doesn't matter. Whoops, I always do that. X plus 6. That's that one. And then what was Sally's line? Sally's line was negative 2x plus 5. And if I graphed them, it looks way bigger than 1. Okay, so now I would clear that. And then I would go do Sally's graph again, negative 2x plus 5. And then negative, I'm just going to show you this, negative x plus 8. Go down, negative x plus 8, graph it, and it's just like 1 steeper. That means your slope is increased by 1. Okay, so that is the review day 1, and I wish it would give me the key here, but it doesn't. Oh, let's see if it does. No answer provided. See, it doesn't let me as the administrator do this. So make sure that you are understanding the process of it. Go ahead and work through day 2 once you are done with this, and keep plucking along.